Hello, my Algebra 2 students. We are on day 7. The notes you're going to notice is just one page. It's kind of meant to be a little bit of a culmination of all the stuff we've done so far. And then there's one or two in the homework packet that I definitely will do with you the next time we're in class, and then I'll let you go from there. All right. So at this point, what you need to make sure that you can do is figure out, excuse me, whether a sequence or a series is arithmetic or geometric, right? And so you should know at this point that if it's arithmetic, it means that you're increasing or decreasing by a constant value. So we are adding or subtracting to get from one to the next. Over here for geometric, it means we are increasing or decreasing by multiplying by a constant value. And of course, multiplying, you could think of it as dividing, all right? So here, your common difference is the variable d. Here, the common ratio, is that value r, all right? And know that you can always solve those. So r can be calculated by doing any term divided by, the term before it. You can make the same argument for d. You could take the second term, sorry, got a little goofy there. You could take the second term and then you could subtract the first term to find that common difference. So you can always calculate things that way. All right, explicit formulas. These are on the Regents reference sheet. So you will have that sheet for your test. It is a sub n and then equals a sub 1 plus n minus 1 times d, where you're plugging in the first term and then you're plugging in the common difference. All right, and then we keep the n parts of it. Over here, a sub n is equal to a sub 1 times r to the n minus 1 power. And again, you'd plug in the first term, and then you'd plug in the r value. For the sequence equation, so if you're given any two terms, you just want to make sure that you can morph the equation. I can write it generically, but I think it's actually easier if I throw two numbers in. So we're just going to give ourselves an example. So if we say like, all right, if I give you the third term and the 12th term, something like that, all right? In that case, put the larger term for the a sub n and put the smaller term for the a sub 1. So we could say that a sub 12 is equal to a sub 3 and then plus whatever times d. The number of common differences would just be the difference between the term numbers. So it would just be 12 minus 3 there. Right? That would be an example here. Right? For this one, let's use the exact same two things. If we had well, actually, maybe change it so you can see something different. Let's say we had the 4th term and we have the 10th term. So in this case, put the larger one over here, and then we would use the 4th term times r to the difference in the exponents there, or difference in the term numbers. So 10 minus 4 would be your exponent. And so this would just turn into 9. That would just turn into 6. As for the series formula, this is the only one that you have to memorize. And it's the arithmetic series formula. So for the sum of n terms, it's however many terms you have divided by 2, and then the sum of the first and last term. So a sub 1 and a sub n. Over here, this one's on the Regents reference sheet. This one, to find the sum of the first n terms, it is the first term minus the first term times the common ratio raised to the n power, and then all over 1 minus r, that common ratio there. And then at the bottom, we have two examples that we can take a look at. So let's do it. The first one, you have an arithmetic sequence. You got the 9th term is 20. The 23rd term is 76. Find the first term and write an explicit formula. Okay, because we have the 9th term the 23rd term, and we're told it's arithmetic, we're going to take that general formula and kind of morph it. So the general formula is this guy. Let's adjust it for what we have. So we have the 23rd term and we have the 9th term. So this would be 23 minus 9 times the common difference of d. So to be able to figure out the first term, we really need to find the common difference first, because that is what we don't seem to have in all of this. So we can put over here that the 23rd term is 76, the 9th term is 20, and we're adding, what is 23 minus 9? 14 of those common differences. So let's solve this guy. If we subtract 20 on over, that'll give us 56 equals 14d, and then divide by 14. So the common difference comes out to be what here? Let's see. So 56 divided by 14 comes out nicely to be 4. All right. Those are usually going to be pretty values here. All right. Once we find the common difference, it's now asking us to write an explicit formula, figure out the first term. All right. Well, we might have to figure out the first term first before we can find that explicit formula. So let's take this general explicit formula and kind of mess with it again. We know now the 9th and the 23rd term, we can use either of those to work backwards to find the first. So maybe I'll use the 9th term, use the smaller of the two. All right. If I make a sub 9 equal to a sub 1 plus 9 minus 1 of the common differences, now I can plug in what I know. I know that this is 20. I need this. That's just going to turn into 8. And we know that the common difference is now 4. So a sub 1 plus 32 is going to equal 20. If I subtract 32 on over, oops, I'm almost off the page there. That means my first term is negative 12. All right. So now we've solved for that first term. Can we write the explicit formula? Yep, because now we have what we need. We've got the first term. We've got the common difference. That's exactly what we need to now write the general formula. So it's going to be negative 12 plus n minus 1 times the common difference of 4. I can clean it up, but I'm kind of out of space, so I'm going to leave it where it is. That's it. All right, let's do a second one over under this geometric column now. So in geometric series, we've got the 3rd term, 6th term. We want to find the sum of 8 terms. All right. So what you got to think about is, what do you need for the sum formula? So come back up here. I need the first term, which I don't have right now. I need the common ratio, which I don't have, but I do know how many terms I want. I want 8. So what we need to do right now is we really need to find a sub 1 and find r. So by giving us the 3rd term and the 6th term, we can mess around with that explicit formula. All right. So I'm going to write the explicit formula down first. That's that guy. Now let's kind of play around with this. Let me zoom in a little bit. So I'm going to put a sub 6 here, a sub 3 here, times r to the 6 minus 3 power. So 96 is equal to 12 times r cubed. All right, if I'm solving for r, divide the 12 out. So r cubed, if we take 96 and divide it by 12, that comes out to be 8. And then I would take the cube root. All right, cube root, I just get one answer of 2. If it was a square root, I'd have to recognize it could be plus or minus, but cube root is just a single answer. All right, so now we've got our common ratio. So we've checked off one box from up here. We need the first term now. All right, so to get the first term, we got to work a little bit further backwards. All right, so that means to get from the 3rd term back to the first term times r to the 3 minus 1. Well, let's see. This is 12. I want this guy. That's now 2. We can quick solve that. 2 squared would just be 4. And divide 4 out. The first term is 3. Now, to be honest with you, the fact that we had the 3rd term and we were only backtracking to the first term, you could probably have just said, hey, let me divide by 2 and divide by 2 again. That would be fine. All right, I'm almost out of space, but we have one last thing to do. Now that we found the first term, we found the common ratio, we can find the sum. So in this little space I've got left, let me fill that in. The sum of the first 8 terms. First term, 3 minus the first term times r to the nth power all over 1 minus r. All right, grab your calculator, let it do the work here. So we've got alpha y equals, and then 3 minus 3 times 2 raised to the 8th power, and then all over 1 minus 2. That is going to come out with a total of 765. All right. So still a pretty big number, not as big as some of the others just because the common ratio is 2 and not like a 3 or 5 or 10 or something. But there's 2 examples kind of covering the basics of how do you take those formulas and morph them to get what you need. All right, guys, thanks for watching. Go answer that post-video question and get ready to do some more work together in class because it's a long worksheet. Thanks.